If you're watching this on YouTube, thank you for tuning in, and hopefully you will find the content useful. So let's go ahead and get started. So today we're going to take a brief, high-level look at the tools, technologies, and concepts that you'll want to be in command of when you sit for the AZ-400 exam. So this training is in no way intended to be a comprehensive preparation for the test. There's just simply no way. This test is extremely in-depth, very wide. And so there's no way in a couple hours that we can cover all the material in depth enough that it would even get you close. However, this training is intended for you to help you focus in on some of the key concepts as a final preparation before taking the test. And additionally, it might be the situation where you aren't ready to take the test, or perhaps you're just starting out on your journey, or you're just not even planning to take the test, but you're interested in these technologies. So this will be a good, useful overview of all of the technologies used in the DevOps pipelines, the DevOps systems at GitHub or at Azure. We're going to take a look at some source control. We're going to dive into building pipelines with CI. We're going to dive into building releases with CD. We'll talk about release management strategies. So you're going to see all this stuff to be a good overview for you. We'll finish up the day looking at some security and compliance, some site reliability, instrumentation, and a little bit with communication. But we're going to focus heavily on the top half of this, and then we'll talk a little bit about rugged DevOps, maybe build a little bit of a security pipeline in place, and then hopefully, if we can get all that working, at least demo some of that for you. So again, this isn't a full, I watched this video and I'm going to be able to pass the AZ-400 test. So please don't have that expectation after watching this if this is all you've done. But again, it is hopefully that it will be something you can use to aid your study, to continue your study, to cram right before the exam, just to kind of refresh on a couple of topics and make sure that you're ready to go for that stuff. Or again, just have that general overview so you at least know what's going on with your DevOps engineers. So this will show some of the processes and tools that DevOps engineers, both administrators and developers, are using to take DevOps to the top level. So there's going to be a couple things we're going to do today, and unfortunately, a lot of things were going wrong for me behind the scenes, and that's no excuse. But getting set up for this, there's a lot of things I needed to spin up and have ready. I didn't get as far as I wanted, but I think we're still going to be just fine. So just know that out of the gates here. But I'm Brian. I'm going to be your presenter for today. I've been working in .NET since it was released to beta in about 2001. At that time, I was just barely messing around. I had been doing VB6, if you can believe that or not. And .NET, VB.NET came out and was quite the change. C#.NET, of course, is where I landed. Most of us have, I think, at this point. There's still, plenty of VB.NET out there, though, so don't worry. Okay. I've had many development positions throughout my career. I've worked with many of the different tech stacks along the way. I started, of course, ASP.NET 1, 2, web forms, moved to MVC, and now we're talking about Blazor and Razor. And, even we've seen, of course, single-page applications with Angular or React. So all of that has been, as a web developer, something that, of course, we've encountered. So in addition to developing web solutions for many different companies, I've also been teaching at the university level for Franklin University out of Columbus, Ohio since about 2010. And have been developing training courses that I have online since about 2013, and you can find those at different places. I currently hold a bunch of Azure certifications, as you can see there. One of them, of course, the most important one for this is the DevOps Engineer, the AZ-400, which we'll talk about a lot in detail today. I have a bachelor's in CS from bachelor's of computer science from Iowa State, and a master's of science in computer information systems that I earned from the University of Phoenix. I have a number of Microsoft certifications. I started all the way back in 2003 with the original .NET 1, got an MCSD in 2007, re-upped the MCSD in 2019, and recently just published a book called Practical Entity Framework, which is available through A-Press. So if you're interested in Entity Framework, you can definitely check out that book. I would love it if you'd connect with me. Please connect with me on Twitter at BL Gorman or on LinkedIn at the LinkedIn Brian L. Gorman. And so you should be able to find me on either. And I'd love to connect with you and hear about your journey, as well as just interact with you and find out what you're doing and what do you think of DevOps and how I might be able to help you. So So if you're watching this today, hopefully if you're watching it, if you're here now, if you're on replay, it's likely that you're someone who at least has a minimal level of experience with Azure, and you've been developing with some major tech stack for at least a couple of years, or you've been administering some stuff for at least a couple of years. So you're well on your journey to being a DevOps engineer. You're not pretty much straight out of the gates. So you've likely been exposed at some point to building pipelines. Maybe you even have worked in some of the architecture, such as an ARM template or a Terraform template that you've used to actually deploy solutions, whether it's from the VM side on the admin, networking, all that jazz, or if it's on the developer side with the app services or web apps or maybe even containers and Kubernetes. And there's so much crossover anymore. We pretty much all kind of work together doing the same things anymore, and maybe a few specialties here and there, but the line is definitely getting blurred. So I always want to just qualify that there really isn't a magic level of readiness for any exam with Azure. You might be, 5 years in and you might not be ready. You might be 5 days in and you might already be a master of this stuff. It's just, it really is up to you and where you're at in life and how much experience you have and what you understand, and just a bunch of other factors that can go in other than just these metrics of I've been a developer for 2 years and I have passed the AZ-400, so I must be ready. That's not necessarily true. So you want to make sure that you have, at least 20 years of experience before sitting for an exam, right? No. You want to make sure that you're ready. But to be ready, you just really need to be able to talk about these things in a way that if you were to present them to your corporation as this is a solution for the enterprise, for us to build out a DevOps pipeline, this is what it means to be a secure DevOps pipeline. This is what it means to have continuous integration. This is what it means to be continuously deploying. This is what it means to work with source control. These are different branch policies. This is Git flow. All of these different pieces, if all of that stuff is making sense to you, then you're probably getting pretty close to being ready for the exam. If some of that scares you a little bit, then just take a little time and learn it. It's nothing to be scared of. It just give yourself patience and time to learn the material. It is a very deep and very wide exam. And so probably one of the hardest, if not the hardest exam I've taken with Azure is the AZ-400. And so do not take it lightly. It's not something that you can just jump into and do. You need to spend a little time with this material, maybe even a couple months, deep diving into some of the MS Learn material and such. So in this talk, I am going to plan to take you on a whirlwind overview of the exam and just basically touch briefly on a couple of the concepts and give you that starting point or that reminder that you would need in a Cram session. Hopefully we'll also be able to help show you some ways to enhance your learning, find resources you need, as well as just expose you to some of this material if you've never seen it before. So let me just take a second here to check a few things. So just want to make sure my microphone's still working, and I want to make sure if anybody's here, if there's any questions. All right, so the AZ-400. Skill Me Up, the company that is putting on this live event for you today that will be played back on YouTube, is the subsidiary of OpsAgility, which I work for OpsAgility as a senior cloud training architect. And so Skill Me Up is our academy, and we have offerings for a number of things. For the AZ-400 specifically, we have a package that you can buy. Now, this isn't a sales pitch, but if you're interested in the AZ-400 and you want to take the official Microsoft course, if you join it with us, you'll get a unique experience. You'll get not only the 5 days of live training with someone like me who is an MCT that has passed the AZ-400, so they have that experience under their belt and have proven their mettle there a little bit, of also just being the MCT in general, having that Microsoft certification on top of taking this exam. There's that. You'll get that 5-day training, which you can, obviously there's a lot of different companies that offer 5 days training, but what we offer at Skill Me Up is a little bit more unique, because not only will you get the training for 5 days, which gives you that chance to have the full overview, the deep dives into the depth that you need for each of these things that we're going to talk about today, but also you get 6 months of access to our academy. Now, with our academy comes live labs that you can work through at your leisure. Excuse me. I'm fighting a little bit of a cough. It's not COVID. Thank goodness. All right, so we have a few things that we offer with the 6 months of live labs. We're able to give you access to run labs on your own. Now, these labs aren't just for the AZ-400. There are a bunch for AZ-400, but they're also for all of our other stuff. So if you get in, you can learn about Event Grid if you wanted to, or you could learn about Logic Apps, or you could learn about network administration. There's a lot of different paths that you can go through on these labs outside of just the AZ-400 stuff. You also get an exam voucher, practice test, and again, 6 months of those labs that you can run at your leisure, which gives you really good practice. We have our schedule online at skillmeup.com/schedule to see what events we're actually hosting and running, and also the mock or Microsoft official courses that we have scheduled that you will get with an MCT if you want to take some of those. All right, so let's talk about the AZ-400. AZ-400 is, again, a very deep and wide exam. So it's rare that an exam is both deep and wide. Generally, you would be wide, but not so deep, and generally, or you'd be deep and not so wide. So unfortunately, the AZ-400 is both. And so there are a lot of things to cover, and it is an expert exam, which makes sense, because by the time you can pass this, you've proven that you're not just, surface level knowledge on a lot of different topics. So in the exam, the actual official exam, there's the AZ-104, which is the Administrator Associate, and the AZ-204, which is the Developer Associate. I came in, I took the AZ-204 Developer Associate as a developer, took the AZ-400. And after studying and taking the AZ-400, I then now have gone back and gotten the AZ-104. My recommendation to you would be to try to get both the AZ-104 and 204. And the reason I say that, you don't have to, you certainly don't have to, but I'm going to recommend that because there's so much crossover between some of the stuff with the development and the administration when you're going to go to the AZ-400. It might be a little easier to come in if you've only taken the 104 and go to the 400 than if you've taken the 204 and go to the 400. If you're like me, more of a developer-centric mindset, you don't have all the networking, you don't have all of the VPNs, you don't have that configuration. You probably haven't, you either haven't worked with containers or you haven't worked with app services. There's all just different things that need to be covered. So if you are a 104 person where you've done all that administration, networking, and you understand that, you're more of the build the pipeline type of person probably than a developer would be. Maybe it might be a little easier for a 104 to 400 jump. But again, my recommendation would be, why not take both? Why not know both? Unless you just don't know how to develop at all, then stick to the 104 400. So just a couple of strategies. So we will cover a lot of these different topics here that are on the skills that are measured. You can get all this online at the Microsoft docs. Just type in AZ-400 and look for the one that's actually the Microsoft docs, and you can download the skills that are measured, as well as some different bullet points under each one of those. I like to just take a moment before I start any training here to just talk about exam tips and tricks. Now, I'm not saying try to beat the exam, but I am trying to say beat the exam. And by that, what I mean is when you go to sit for the exam, you're going to be asked questions across all of these topics. So each one of these has a weighting. So if we look at CI, 20 to 25% of the test questions will likely be in the CI. So if you haven't worked with CI, this is a really good place to start. Start with the bigger ones. Start with the ones that have more weight in the exam. Now also note that some of them are a little smaller. So instrumentation is 5 to 10%. Site reliability engineer is 5 to 10%. Let's say you're really good at instrumentation, but you don't really know site reliability. Then your best bet is probably to just study site reliability and not study instrumentation if you're trying to get your last minute studying done. And the reason I say that is because it's a lot easier to move the needle if you move the thing that you're less good at. So becoming an expert in something is awesome, but moving the needle from 90% to 100% in something that's weighted 5 to 10% of the exam versus moving it from 40 to 70% in something that's weighted 5 to 10%, you can see where your gain is going to be more useful for passing the exam. Now, again, it's not a good idea to just try to beat the exam and just be like, well, I'm going to memorize a few things and hopefully get to the exam and they'll be on there. That's a terrible idea. You're better off making sure that you can actually do these things. And these exams are really good at proving that out. They make you prove that you understand the material, not just that you've done really good things at memorizing a few charts and tables. So broaden your knowledge, find the things that are the most expensive on the exam here, learn those well, find the things that you're not as good at, learn those next, finish up with the things that you're becoming an expert at. Every exam is pretty much the same anymore. There's just a few differences here and there. Generally, they're 2 to 3 hours depending on the level of the exam. This is a expert level, so it is a 3-hour scheduled exam. You'll have approximately an hour and a half of that, or 2 hours and a half of that, excuse me, answering questions, and then 5 to 10 minutes on each side of surveys and stuff that doesn't count against you, feedback, reviewing your score. The exam is anywhere from 40 to 60 questions. I have no idea how many questions will be on your exam, and even if I did, I couldn't tell you, but I can tell you that it's in this range. And basically, the reason that it changes is because they have many different versions of the exam. So if you go back to take the exam again on a second try, you likely will see completely different questions than you saw the first time, which is good because it doesn't let you just figure out the answers you didn't know and pass the test the next time, but bad because it means that you never know what you're going to get, right? And that's why the weighting is there and the number of questions are there. And so just make sure that you've prepared across the board and that you give yourself time to take this exam. Don't rush. I think you'll find you have plenty of time. When it comes down to it, most exams now have the same types of questions on them. You never know what you're going to get, but generally you can expect a few of the same things, which would be obviously a bunch of multiple choice questions. Some of them might be, you have drop downs where you have sections of code and you're trying to fill in the right pieces of code. You might have, 5 different things on the left-hand side, a bunch of stuff on the right-hand side, and you have to drag and drop things in order. You might have a full business case where they actually expect you to read through and understand all of the requirements, all of the security issues, all of the problems that exist, where the company's planning to go. Everything that you would need to be able to do as a DevOps engineer in the real world presented to you in a question. And then those scenarios might have anywhere from, 4 to 10 questions around them or something. I don't know how many you'll get, but and you may get 1 or 2 or 3 of those. I don't know. It just depends on the exam you get. And then also the one that always I like to talk about last is this one-time only questions. These tripped me up once, and I've told this story. So if you've watched other videos I've done or had training with me in the past, you've probably heard this story, but I have to share it because if nothing else, maybe it'll help you. So when I first started recertifying for the MCSD back in 2018 or 19, I can't remember, I went and took a 7487, 7486, and 7483 to get that MCD. Those were C#, Azure, and web services, and I can't remember the other one. Anyway, oh yeah, MVC5 or something. And so all this stuff was there, but I hadn't taken these exams since 2007. So a lot of things had changed. And one of the things that happened was I was presented with these one-time only questions. And in these questions, it's generally a scenario and then a yes or no. Does this solve the scenario? And you don't get to go back. So this is why they're hard, because once you answer it and push next, you cannot go back. And the reason I think for that is really kind of straightforward. It's basically, you never know which ones are going to solve it. And maybe when you see something else, you realize the other one would have solved it, but it's too late at that point to go back and change it. Well, I read the question and I started answering yes or no to the different scenarios. And I got to the 4th one and I said, that doesn't even make sense at all. And I'm pretty sure I pushed no because it didn't make sense. And then I realized the question had changed. So just be careful. If you get these one-time only questions, make sure that you're reading the question before you hit yes or no, because even you get honed in on the scenario, and this is, if you're still thinking of the first question and they put something out there that doesn't make any sense at all of a sudden you might realize, oops, the question's obviously changed. Make sure you reread the question. So anyway, that's just my 2 cents. Okay, so I need to cough. Hold on one moment. All right, sorry about that. All right, so this next part, we're going to talk about source control. Now, I'm not going to spend a lot of time talking from this point on. I'm going to talk a little bit, and then we're going to do some demos, and we'll see how long it takes us. I think we'll probably be done here in another hour and a half or so. I don't have a lot of talking that I like to do. If you are someone who likes theory and wants to go deeper with that, there is so much documentation to read on all this stuff, and you can definitely do that. I'm much more practical. If you've ever worked with me or if you've ever attended my trainings, I'd much rather would see it and do it than talk about it. Now, talking about it's good, and there's a very good level of why you should talk about stuff. But once you start seeing it and doing it, in my mind, it starts to become more solid. And then going back and reading and talking even more is a great idea. So today we're just going to touch briefly on a few of these concepts, and then we're going to dive in and do some demonstrations. And we're going to do them live, and there's going to be disasters. I'm just going to warn you up at front that things are going to work and things aren't going to work, and we'll just adapt as we go. So just have patience with me on those live demos, because this is going to be a lot of stuff, and there will be things that I'll probably forget or make a mistake here and there. So just have a little bit of grace for me, and I really appreciate that. All right, so we got managed source control. So this is a 15%, I believe, I think, of the, 10 to 15%. So if you've never worked with Git, you definitely want to spend a little time learning Git. That's pretty much the main player in the world now. But let's go back to, 2000, early 2000s, even before that. And then in the late 90s, there's, they've had source control for a long time, even before I started developing. But let's just start with VSS 6. Yeah, VSS 6. If anybody remembers that and the nightmare of a corrupt repo, then I feel your pain, and we've been there, done that, and thank God we have Git now, right? So if you're scared of Git, or if Git's giving you a problem, trust me, it's been worse. Okay, so we had centralized source control. We had VSS, we have Subversion, and eventually VSS became TFS. TFS was a centralized source control that we used, and some people still use it. It's perfectly fine. Some people still use Subversion. It's perfectly fine. There's nothing wrong with it. There actually are places and reasons that you might want to consider staying with centralized based on some different performance things and sizes of your team, sizes of your repos, all that jazz. I would still recommend everybody move to Git at this point, but I get why people want to stay where they're at. So centralized. There are a couple of molecules that I decided to use as examples here. So the first molecule that you see is a water molecule, H2O. So there's 2 hydrogens and 1 oxygen. So you see centralized, the oxygen molecule is kind of the base, and each of the hydrogen are connected to the base. And so the whole molecule together is one thing, but ultimately there's one central location. So this is actually kind of a terrible example, because in a centralized, what happens is you're actually going to bring the whole repo, down to your machine. You're bring it down, but everything that you commit and everything that you work with and do as far as branches and changes, all of that has to be pushed back and done at the central source. Now, over here on the other right, I think this is a buckyball. I'm not exactly sure. Carbon 60 is a buckyball. If you've ever taken chemistry, you should know that. But anyway, if you haven't, a distributed system is a lot like this, in that every single node is its own copy of the repo. And this is where the benefits come in. Corruption. So a centralized, if the central oxygen molecule decides that it's going to, I don't know, blow up or something, and it's gone, all of a sudden everybody's down. There's no fixing it until you fix the central repo. If Git, for example, in the distributed, if one of these nodes happens to go down, every single other node could restore it. So now everything's distributed. So if we have, we still use a centralized location that we use as our main, such as GitHub or Azure DevOps or GitLab or Bitbucket or TFS Git. Those repository providers. There's a couple others as well, but those are the main ones that you likely are using. One of those. If that goes down, we can restore it from our developer machine. We just basically take the history and the copy that we have on our local machine and put it back at GitHub. Now that might there's a few things to solve with all of that, but it's generally much quicker, much easier to restore than if you're working with a centralized version. And so the main player, when it comes to pipelines and when it comes to deployments anymore, everything is done through Git at a central place such as GitHub, Azure DevOps, GitLab, Bitbucket, TFS Git, which really kind of lives in Azure DevOps now. And so you have that central place, but everything is still using a distributed Git source control system. So you need to learn the commands of Git. You need to understand how to do, things like check out your code, make changes on branches, push your code, create pull requests, manage all that as a development team, maybe even manage that as an admin team with some of your ARM templates and different infrastructure as code. That is a big deal now, especially with DevOps. And so, yeah, everybody should learn Git. I don't care who you are. If you don't know Git, learn it. It will definitely take you farther, and it will help you in your career. There's no reason not to learn it if you're going to work in DevOps, if you're going to work in code, if you're going to work in infrastructure as a code, any of that. Start making sure that you're good with Git. There's lots of tools you can use: Visual Studio Code, GitHub Desktop, Git Kraken, SourceTree, Tortoise. There's 100 others. There's also bash terminals that run Git. You can run Git from any command line. So my personal suggestion to you, although it might be scary, is learn the commands first in a command line and then learn an IDE on top of it to ease your life. If you just can't do that, start with one of the pre-built tools that actually helps you really well, like a VS Code, VS, Visual Studio, GitHub Desktop, or Git Kraken, or SourceTree, possibly Tortoise. I haven't used that one, so I'm not exactly sure how good Tortoise Git is. But I can tell you that the other ones each have really good things, and so I'm not advocating for any of them. I personally live in the VS Code, VS, and Terminal most of the time. But GitHub Desktop and Git Kraken are also very popular with developers I know and have things to offer. And SourceTree is, I believe, the Bitbucket Atlassian version of the tool, and has nice little, chain. You can see the commit chain in there. Git Kraken also, I think GitHub Desktop also show the chains, where VS and VS Code don't do a super good job of showing your commit history chains all the time. You can definitely see them, but I think, Git Kraken, SourceTree, those are kind of more of a central point of the tool to help you visualize things. So yeah, learn the commands, then learn the IDE, become a master of Git, and you'll go a long way. So we're going to do a couple demos today, and to get started, we need repos at GitHub and Azure DevOps. And unfortunately, my demo account that I was trying to set this up for all morning won't let me run Azure DevOps pipelines for some reason, so I had to switch back to my own personal. So I'll have to do this from scratch in some of my own personal stuff. It won't hurt the world, but it just might take us a little bit longer than I had planned. So we're going to create a repository at GitHub and a project at Azure DevOps that will have a repo in it. So let's just pull up a browser here, and we'll dive in. Let me make sure that I have everything mostly hidden so I don't give away the world here by accident on secrets or commands or anything. All right, so the first thing I want to do is go to GitHub, and I'm just going to use my own personal account here. And so I'll just go to my repositories, and let's just do a new repository. And I'm just going to call this one Simple Web. I'm going to call it GitHub, Simple Web GH, just so I can keep things straight in my head. Simple Web GitHub, and it's going to be, I'll just leave it public. I'll probably tear this down after this demo, so don't look for this online. I'll be probably redoing this at some point in a different way, but just know that this is probably just going to be gone by the time you get there. Simple Web demo with actions. Maybe I'll leave it up. I don't know. You just never know. I'm not going to put any README, get ignore, or license in there, although I ordinarily would. I'm going to go ahead and leave that off. And note that with GitHub now you have Dependabot preview. which is really nice. It's a DevSecOps thing. It's security. It's going to scan my repo to make sure I don't have any bad stuff in it. And if it does, it will actually start creating pull requests for me. So just to quickly show you one that's actually done that, if I take a look at some of my repos here, and let's see, I have, let's do the boilerplate. So ASP boilerplate demo. All right, so the ASP boilerplate demo. So this is an open source project done by Volosoft, and they are an awesome company that does some really cool stuff with ASP.0 and this ASP boilerplate that I've been working with their technology basically for the last 4 or 5 years as they've grown. I love their products. So I used to do talk on ASP boilerplate, and this is from that. The whole point of this is that this one has dependabot alerts. So I haven't done anything with this for months. I used to see like a year and a half was the last time I did anything, or yeah, a while ago. But look what dependabot did. Dependabot actually has gone through and scanned. Since I haven't updated the repo, I'm so far behind the latest version at this point. You see that I have a lot of security issues, and you see that it's opened this one even 16 days ago. It says you need to get elliptic, you need to get HTTP proxy updated, and it opens those pull requests for me, and I can literally just come in and merge it if I'm okay with that. Now you need to be a little careful because obviously that's a bad deal if it breaks my code. So you would want to double check and test everything, but isn't that nice to have something automatically scanning for vulnerabilities and I didn't have to do anything extra? And it even opens pull requests when it finds them. That's pretty sweet. All right, so this is my GitHub. Let's go ahead and go to DevOps. And let's just create a new project here, and we'll just call this Simple Web. Well, let's call it AZ-400 EC Simple Web. I'll put ADO on the end of it, and I'll leave this as a private project. This is just a demo Simple Web. So I'm going to go ahead and create this. Notice there's an advanced tag here, my version control. I can use TFS Git or Team Foundation version control or Git. And then I have Agile, Basic, CMMI, or Scrum as my choices. I generally just start with Scrum. If I need to change it, I'll do that later. So this is going to create my project at DevOps. DevOps is free, so if you have an Azure subscription, you can create DevOps for free. There are things you have to pay for if you want to up your pipelines, if you want to have multiple parallel runs. All that jazz is stuff that you will need to know actually or understand a little bit for the exam. So it's not like I'm completely telling you things you don't want. But note right away that this has a repo. So we have this repo for, major guidance, Dev Azure, and then the name of my deal here. So each one of these, Git and Azure, will tell me exactly what I want to know as far as connecting. Now I have a basic simple web here that I've actually I just spun this up. It's a .NET 5 ASP.NET web. It has authorization in it. So let me just run this locally, make sure it works. Which, I've done nothing with it, so if it doesn't work, then the template has a huge problem, right? But let's just make sure we can do this. Excuse me. All right, so if I register here, we'll just leave Bob in there. It doesn't matter, this is local. All right, so I haven't run my migration, so let's go ahead and do that. Ordinarily, I would do that through the update database command, but we want to make sure that works. So let's refresh the page. Let's see if we can, yep, we registered, confirm my email. So let's go ahead and log in as Bob. Okay, I'm logged in as Bob. So super awesome, simple web solution here that does nothing other than register users and has everything set up ready to go for .NET in the ASP.NET MVC .NET 5 ecosystem with EF Core 5. All right, all that cool, awesome. So now what I want to do is add this to source control. So what I'm going to do is I'm going to find this in my local files and folders. And so that's here at AZ-400 demos. So simple web solution, there's the stuff. So let's go ahead and git bash here. So there's a billion different ways to get started with setting up repos. I'm going to use commands again. If you know how to do this with your IDE, please feel free to do that. You don't have to follow along everything I'm doing here exactly the same way. Let me just make my font just a little bit bigger here so this is easier to see quick. All right, so you see here I have simple web solution, and if I just did a quick ls command, you see that there's the solution and the nested folder. If I do lsal, you see I've got my git ignore in place already. So I already dropped one in because I knew that I was going to do this and I'd forget. And so git ignore, all that is I got this off the web, and it's just going to let me ignore all of the folders and files that I don't want in my repo. So if you're not 100% familiar with this, you don't want shared files or generated files in your repo. You don't want the conflicts that would cause. So you see this is eliminating debug and bin and object and things like that. These are the folders that are created by default in a .NET project. And if you're doing Maven or Java, you get a Maven or Java version of the git ignore, not a .NET version. And it will have all of the things like .class files for Java people that you don't want to include in your source. And so make sure you have your git ignore in place. And once you have that, then you can actually create your repo and not have to worry about pushing the wrong stuff. So we're just going to say git init to create a repo, and that initialized it. If I say git status, now you see that I have untracked files and unmanaged files for git ignore, the solution in the solution folder. So I'm going to go ahead and just do a git add dot, which some people say never do. I'm going to say do it with control, and in this case we're adding everything we want. So rather than try to name each file individually or each folder individually, I'm going to add dot to add all, and that puts everything into a stage. So here you see I have a whole bunch of files that I've added. If I do the full status, you can see they're new, all that jazz, and they're green, which means they're ready to be committed. So git commit -a would add. They're already added, so I don't need to do that. So just do M, and then the message here would just be initial commit. So now I have nothing. I'm on branch master. Let's just do this. Branch master is now branch main by doing that command. That's how easy it is to rename your branch and get off of the keyword master onto the keyword main. The keyword main is actually much more prevalent in legacy source control. So a lot of people are used to using main to begin with, but there's social reasons that we've all gotten on board with and agreed with to switch these to main going forward. And with a simple command, it doesn't break anything. You know, there's no reason not to take advantage of that. So now we're on main, and everything's going to work just the same. I'm still git status and stuff. So let's just see right now I have no remote. So I don't have any remote. And so what I want to do is I'm going to use this same repo, and I'm going to push to both Azure DevOps and GitHub. And a lot of you maybe haven't seen that before. So this hopefully will be cool. It's just a cool thing to learn real quickly. So we have, here's our Azure DevOps. Let's start with GitHub. So GitHub tells me exactly what I need to do. Git remote, add origin, HTTPS, simple web, git. This is my clone or my remote location. It tells me to rename the branch to main. And then it basically says push origin main. So I want this first command, git remote, add origin. And so origin is nothing more than a variable. Now, so I'm going to leave origin for this one. So GitHub is going to be defaulted by origin. If I don't say origin, it will default to origin, which means it's going to default to my GitHub instance. So that's just important to note. And then what I'm going to do is go ahead and git push -u origin main. You could do --all here if you had other branches. I don't have any other branches, but what we'll see here is that by doing that now, I have my repo at GitHub. Perfect, exactly what I wanted. The only things that are in there are the folders and files that I wanted. I don't have my bin folders. I don't have, anything else I don't want. So this is my default stuff. I do have app settings, so I need to be careful about secrets. That's something else we'll talk about a little bit as we go through this code and stuff today. So let's stick to this. All right. And then the other repo. So now it's going to be a little more tricky because I'm using two repos. So I clone this current URL if I didn't have anything. And if I cloned this, it would just say you've cloned a default empty source control. That doesn't make any sense. And I say, I agree. So let's just once again do git remote -v. So here you see I have my origin, which is pointing to simple web. Let's just do a git remote add, and then we'll just do ADO. instead of origin, and we'll name it this way. So now I need get remote add ADO, and this is a little bit longer. The syntax is a little bit longer for these repos than it is at GitHub, which is fine. It's just a URL. Don't freak out. Now if I say get remote -VV, you see now I have ADO, which points to my DevOps, and origin, which points to my local. Now I don't recommend doing this for most things because you really don't want to be managing source control in two different places, especially from the same folder. It's kind of a terrible idea, but for this demo, it actually works well. So now I'm just going to do git push -u, and then I'm going to do ADO main. So now I'm going to push to Azure DevOps, and I've already got all of my credential manager stuff is all figured out. So I didn't have to log into either. You might have to if you not got that set up. But you see now Simple Web Solution is also out at ADO. So we learned a few things about Git here, just basically getting started, setting up our repos. We created a repo at ADO and a repo at GitHub. And now we're ready to start working with those in our different solutions. So I wanted to also do a couple demos on Git commands, just out of the box. So you can always do, we saw it already, git status. That's the full git status. There's nothing changed. Notice this is saying it's up to date with ADO main, which is interesting because it's the last one I pushed, which might, again, be interesting once one's out of sync, what things would be said there. But let's go ahead and just check out a branch. So you can do new branch commands, but I usually just do git checkout -b and then the name of my command. So we're just going to call, or name my new branch, sorry. This is Brian Demo. So now I'm on that new branch, and then, if I do my status, you'll see I'm untracked at this point. I don't have anything going on, nothing new. And so let's just go ahead and touch a new file here called readme.txt, and that's going to create it, and then we'll go ahead and code, which will open up the folder in Visual Studio Code. That's added to my path, so that's why that worked. Here's my readme. And then we're just going to do, simple web AZ-400 EC demo. And, this is the demo repo from the EC video you are watching. Like that. And once I have that, now I have my status. So I've readme. I'm going to go ahead and add. I can do add readme directly and just add that file. It's the only thing that's untracked, so I'm just going to go ahead and get add dot. Since it's an untracked file, I can't do a commit and add at the same time. That's a different. You have to get that once they're both there. So git add, git commit -m, and this is going to be the repo added readme. Okay, and then I'm going to go ahead and git push. Now, where do you think this is going to push? Nowhere, because it doesn't know where to push it. So I have to tell it where I want to push it. And especially with two repos, that's even more important. Since I created the branch locally, it's not tracking an upstream. So let's do git push -u origin, which is GitHub, Brian demo commands. And just to keep everything in sync, let's do git push -u ADO Brian demo commands. So now it's going to push out to Azure DevOps as well. So then in each one of those, I have to pull up the, did I lose my browser? I think I might have accidentally deleted my browser. Darn. Okay, sorry about that. Get back to GitHub and my repos, and I struggle with the GitHub interface sometimes finding the repos I'm looking for. I wish it did a little more stuff. So this one says compare and pull requests. So I'm going to go ahead and create a pull request here at Simple GitHub. I'm going to add the README, and we'll go ahead and create the pull request. And then, of course, everybody else can then validate. If I had any GitHub actions, they would run here. We'll go ahead and merge that, get that merged in. And yeah, this is where it's going to be a big problem, because once I do this, we're going to get different commit IDs at GitHub than we'll have at ADO. So that's going to be a pain. So we won't merge this. We won't merge the ADO one back into. We won't do it from a pull request, or we'll have multiple things going on. So Azure DevOps, dev.azure.com. Just going to go to my simple web ADO. And again, here I would also have the ability to create a pull request, and it would tell me, you know, here I can go ahead and see what's going on and all that jazz. So I'm going to go ahead and skip doing this one since I'm using 2 repos. You get the point. Create the pull request, have your team review it, merge it in, etc. I just don't want to create conflicts that I have to deal with. So let's go ahead and get checkout master main. Sorry, forgive me. So at GitHub, we actually have updated main. So let's go ahead and get that, git status. And so it's 1 ahead of ADO main by 2 commits, use git push to publish it. So I need to go ahead and just git push ADO main. I don't have to do -u because it's already tracking that at this point. And now ADO should be up to date as well with my repos. So you see readmes there, just like you would expect. I didn't get a conflict because I expected it to happen, so I avoided it. Ordinarily, you wouldn't be working at multiple repos, right? So we saw how to create a branch, we saw how to push it out there, we saw how to do a pull request. That's probably good enough for now. Eventually, we'll see some stuff on potentially doing other things, but let's talk about Git branching strategies. So as you do branching, you're going to start working with branches, and generally the recommendation is some sort of Git flow type of scenario. Git flow, the main things you want to take forward are that you never, ever push to your main branch directly, and you don't have teams pushing to your main branch directly. Instead, what you do is you create a sub branch called develop. In develop, then your teams can work against develop and create their code and work against their code correctly and not mess up your main. With that also, you keep your feature branches off of develop, and then if a patch needs to happen, such as a bug, you can check it out. They've used tags here to tag versions. You can check it out. A tag is nothing more than a bookmark to a commit. So you could use a direct commit if you need it, if you're not using tags. Either way, I suggest using tags though, because it's nice for tagging your releases. It creates releases automatically at GitHub. Hot fixes, then you get the fix in, you push it into your main branch as your development or as your production, or basically release into your pipeline for test, then to QA, then to production, however you're going to set that up. And then you have your develop branch that you're pushing into as well. So now the developers and the main branch have it, and your developers can then integrate their code against that, make sure they're not going to further break it going forward. Also, you can create a release branch once you get to specific points, and you can patch that and work against that as well. And ultimately, this kind of a branching strategy gets you some really nice code congruency and keeping things in place so you don't have conflicts and you don't break things often. Now, there's a couple different ways you can go about this. You can have one repository which has that dev branch, and then everybody else is working off of that dev branch, which is great if you're a smaller team of 7, 8 people. But if you're a big organization, you likely have departments, you likely have development teams. In that case, it doesn't make sense to have everybody working off the same development branch. At that point, what you're going to want to do is find some kind of Git workflow, such as dictator and lieutenants. You can read about this stuff online. It's way outside the scope. But basically, at that point, you have your lieutenants would be like your departments, and in each department would work against their lieutenant, and then the lieutenants ultimately would merge back into the dictator, and that's what's going to be your source of truth for the entire organization. You can have pipelines off of any of them, so you don't have to even work together, but it's just really nice to make sure that if you do, you're not breaking everything. And in that situation, you're going to be using forking. Forking just means making a copy of the repo from a specific commit. To get it back in, you have to get approval across the repos from only the people who are allowed to do it. So really good examples is if you ever worked open source, if you've ever done anything with Microsoft code, they have a bunch of repos out there. you can fork their repo, you can then change code, and you can request the changes go in. You can't actually, the fork can't update the base, and so it protects the base from being unauthorized changes against it. So the people who own the fork, then the fork's base, have to approve the pull request from the fork back into that in order for it to go in. So it's a really nice way to protect your code from other people making changes, but also expose it to them to extend it and give them opportunity to ask you to include their changes in your code base. So just a little bit more about Git. If you with Skill Me Up, we do have a couple of labs available, version control with Git and Visual Studio Code and Azure DevOps to learn on that. All right, so we've talked about Git. Now it's time to talk about CI. So CI and CD, do you know the difference? You should. If you don't, there is a difference, and it's important. And so CI is going to be our continuous integration, and CD is going to be our continuous deployment. CI means that every time I check in my code, there's a build continuously integrated into my build process. Continuous delivery, or CD, continuous deployment, means that eventually, at some point, it's getting deployed into some environment, whether that's dev, test, production, whatever it is. That continuous delivery can be automated. So continuous integration should automatically be automated by everybody. Even if you're not going to do continuous deployment, you should at least build a pipeline to build your code and make sure changes are scanned and applied and the build doesn't break. It can save you a lot of headaches. As we go through everything with Azure DevOps, we're going to be talking about moving quality left. And so by putting in a CI pipeline, we're going to determine whether or not builds work at the time of check-in rather than when we try to build them to push them to production. And so moving that quality left, moving those checks left, that's our goal. And same thing with security eventually. In our rugged DevOps, we want to move everything as far to the left as possible, because the sooner we find it, the less expensive and costly it will be for our organization, and the less damage could possibly happen if we get it corrected early. So CI. CI, again, is continuous integration. Here is an example where we have an engineer and they work in Visual Studio. They commit their code into Azure repos. It could just as well easily be GitHub, GitLab, Bitbucket, whatever your flavor of repo is. Just exchange that with Azure repos there. And the pipelines, whether it's GitHub Actions, Bitbucket Actions, GitLab Actions, or Azure DevOps pipelines. They're all the same thing. They're all going to use YAML. They're all going to build out your code. And generally, we'll talk about this in a second, what we want to accomplish at the CI level. And so we have our pipelines that are being built, and a lot of times then this is saying, Azure Web Apps and Application Insights are included. Maybe there's either an ephemeral environment that the developer has only spun up just to see that things are working for testing, or perhaps your continuous deployment starts happening in this pipeline as well, where you push to test or push to a dev environment of some sort, some dev test environment. Application Insights, of course, is the monitoring and stuff, the feedback that we'll talk about towards the end today. In your CI process, you should accomplish the following things: scanning your code. There should be something in place to do that. We talked about Dependabot, but also there's a couple other major players that are easily integrated for free into your solutions. You have Sonar Cloud and WhiteSource. WhiteSource Bolt is a nice little add-in that scans for your NPM packages or your NuGet packages, making sure you don't have third-party dependency issues, which we'll talk a little bit more about in rugged DevOps security stuff later. Sonar Cloud is going to scan your static code. So it's going to analyze your code for smells, for bugs, for potential things that you should fix. And so both of them are very valuable tools. Both of them are available for free, can be integrated directly into your CI pipeline, immediately then scanning every check-in, basically that's creating a pull request into your whatever develop branch, and essentially saying, let's go ahead and scan this, identify any code smells, any issues, any dependency problems that we can right up front, and fix them. So you're going to scan your code, you're going to restore any dependencies in your pipeline. So this means pull down your NPM packages if you don't have them, pull down your NuGet packages. It's going to then build your project and assure the build completes with the new code and doesn't fail. That might be using MS Build, or it might be using some other tool to build your code depending on if maybe you're linting JavaScript or you're linting JSON or something, right? There's all kinds of different things you can do at a build process to ensure your code isn't going to break and follow standards. And then the test. So generally you run your unit tests at the end of your CI process right before you create and publish your artifact. So the end result of a CI process should be a fully built, published artifact that has been scanned, tested, and has all of the things that it needs in order to work in your production environment. However, you don't deploy it directly to production. There's a couple things you want to keep in mind about your artifact. It should be immutable. You should not be able to change it once it's built. And this is very important because this prevents people from injecting the wrong things into your code package. So if I can change the package that's gone through the scan, build, restore, test process and change it because I discovered a bug and I don't want to run the whole process again, then that's really bad, because maybe I could also inject a third-party library that we didn't scan that suddenly has this dependency that gets us in really big trouble with, somebody. So that artifact should be immutable. It should be published somewhere for further action. So your CD pipeline, which could be the same process, you could have one giant YAML file that does everything, as we'll see in GitHub Actions, or you could have a CI pipeline and a CD pipeline for releases, as we might see in Azure DevOps. And you can always do everything in YAML, even in Azure DevOps if you want to. That artifact should be in a drop location that can then be used in the next part of the process. Things we're not really touching on today because I'm a developer that doesn't use containers. I'm not going to touch a lot on containers, but you need to understand them. You need to understand what they are, how they work. You need to understand what Docker is, Docker files. You need to understand how to build Docker files, how to run Docker files or run your containers, what a container is, why it's better than a VM, how that all works together to play nicely. And then you have Docker with Docker Hub, and then you have Docker with Azure Container Registries. And Docker Hub and Azure Container Registries are basically the same thing. It's like a repo for your containers. And so with Azure, we're going to use the ACR. We're going to publish our images, which are our container images, into the ACR. And then we have choices. How do we want to host it? We can host it through ACI, which is the Azure Container Instances, which is a lightweight container hosting environment. Or we can do it through app services for web apps, or for Linux, and be able to then host up our container app service containers. And then also, we didn't talk a lot about this, but we also want to be able to understand that app services for web apps in the .NET world or in the Java world or in the Python world, those are all important too. And finally, the dreaded Kubernetes. And I say dreaded because it's so popular. Everybody loves it, and it's great. It's honestly great. But when you haven't worked with containers because you came from the .NET world, always working in Windows and IIS, it can be a little bit scary, just like Git. So you'll need to know it though. So get used to working with containers, get used to building containers and deploying containers, and then learn more about Azure Kubernetes Service. You're going to need to understand it in order to do well on this test, most likely. So. All right, so the next thing I wanted to do was build out a couple pipelines. And so what I'm going to do here is I'm actually going to start with a GitHub action. And there's a couple different pipelines in ADO. So this demo is supposed to be ADO. So let's start with ADO then. Create a pipeline in ADO is a little bit different than what you might be expecting. There's two different ways to do it. Sorry. Okay, so you can start with a new pipeline using YAML, which is the recommended way and definitely the way you should do it, unless you have reasons. But there's an easier way. So the easier way that you shouldn't do is to use the classic editor. This is the way that it was done in the original Azure DevOps. It's still here. It's still useful. Let's do an ADO pipeline here with the classic editor, because the reason this is kind of nice, especially if you've never worked with pipelines, is it's drag and drop. So let's go ahead and we want to go ahead and create our pipeline here. So our team project is the team project. This is the repository. This is the branch we're going to build. You can do different branches. So if I wanted to do a different branch to deploy to some sort of version or whatever, I can easily do that. But I'm going to just do everything off the main here. And I'm coming from Azure, but you see there's other, other Gits you can use, other places you can get stuff from. So again, they're going to say, hey, you sure you don't want to just do this with YAML? Because we really think you should do it with YAML. And if you do that, you go back to the other way. Okay. It says try the new YAML pipeline experience. Okay, we're not going to do YAML. We're just going to do .NET. And this will be interesting because I've not done the classic for a .NET 5 project, so this may not even work. Let's do ASP.NET and see what happens. All right, so it's saying it wants to restore with NuGet 441. Hopefully that'll work. And so if there's an older or newer version of NuGet, I might be able to pull that in. NuGet restore is just going to run that restore command to pull in any packages. You can use feeds, or you can, use NuGet's config, but you can set a specific feed if you want to use, if you want to bring your packages, or you can use NuGet.org. Now there's also a thing where you can do some hierarchies with the artifacts here. So we'll probably not get to artifacts today, but with artifacts, you could actually publish a source pipeline of artifacts. So you could bring in all the NuGet packages and use this as your primary, but then you could set NuGet.org as your failover or your failover. So if something goes wrong with your local artifacts, it will actually go back to the regular NuGet to make sure you have a version. So this is going to try to do build. So I'm not sure that this is going to work because I'm thinking we actually need .NET commands, test, .NET test should be .NET test here, and then publish and publish. Well, let's see what happens if we do this. Let's save and queue this pipeline and see, let's run it on latest Windows. We could even probably run this on Ubuntu, no problem, because it's a GitHub, or excuse me, it's a .NET 5 project, but this probably will fail. Just my guess out of the box here is just the wrong version of .NET with this classic pipeline, and that's okay. So while that's running, let's go ahead and create another pipeline. And in this one, let's use YAML. And we'll bring in ASP.NET Core this time, which is definitely what we want. And you see here that this is going to be all YAML. So the syntax is going to be similar but different depending on which version of Git you're using, which version of Git repos you're using. So here we have triggers. It's going to trigger on main. The pool is just where it's going to build. This is the Windows latest VM image. The solution file is what I'm looking for, build platform and build configuration. So I can change these as variables. If I want to change to x86, I could do that. If I want to change to debug, I could do that. And then you have steps and tasks, and then stuff that you do in the tasks. So here we have NuGet installer, VS build, VS test. This doesn't have a publish step. We need a publish step. So I'm going to steal one from one that I have that has one, if I can find one. Hopefully this has a pipeline. It doesn't. Okay, let's find one that has one quick. Contact web. Let's see. This one will have one. So let's grab a publish step. We need a publish task because once we build, again, we need to drop our archive. So we need to publish here. This, and then we need this to be at the input level. So this is where YAML becomes super fun. All right, so I believe that's going to do the trick. So we're going to try to publish the artifact basically to a drop called artifact staging directory. So again, we want to do the file. We want to have our pool. We want to have any variables for configuration we're using when we're doing .NET run here, running the tests, and then ultimately publishing the artifact. Let's try to save this one. And this also has to be committed directly to the main branch because now I'm creating a YAML file that's going to go into my main branch. So this will be queued. If the other one isn't done, it'll have to wait. Let's see what we have here. So this one did fail. Doesn't surprise me. It's the wrong version of .NET. Yeah, so it's not compatible. So let's go ahead and just wipe that one out. The whole point of that was just to show that you can do that. While this is failing, then let's go ahead and I'll show you one that is working. So while this is running, I have another project here called the Parts Unlimited demo. And in here, it's just code that came from the DevOps generator and the Parts Unlimited pipeline. I've already run this to make sure it's going to work today. So in here in the pipeline, this is using the classic. Let's see if we can edit this. This one's doing NuGet restore, build solution, testing, copying, and publishing the artifact. So everything that we want is here. Also, just note there's variables up here that you can change, triggers, so you can different things you're triggering on, different options you can set on your build, retentions and history on your different builds that you want. So just be aware of what these tabs are for and what they do, and know that your build has to have that publish at the end, and you're basically building out your testing and all that jazz. So hopefully at this point, the Parts Unlimited, the other version, yeah, sorry, this is the one I was just on. Simple Web ADO, still running. Okay, so while that's still running, let's go do a GitHub action. So now GitHub actions are really interesting because I just go to actions and I say I want to do something. So this is going to say, what do you want to do? Do you want to do .NET, .NET Desktop? Do you have some other things you want to build? And you can select those out of the box, or you can just set up your workflow yourself. I'm going to take the .NET version here because this is .NET 5 and this should work just fine. So see, this one's going to say on push to my branch main or pull request to my branch main. So depending on how I want to build this, I can do different triggers. I still have my jobs. I have my runs on Ubuntu latest. So this is my agent that it's running on, and then the steps. We're going to check out the code. We're going to use .NET version 5. We're going to restore dependencies, .NET restore. We're going to build. We're going to test. So once again, there's no publish here. So we're going to need a publish step at some point. So let me grab one of those that I have. And let's see if I can find the one that works. And grab that code. So here we have .NET test. Yes. Okay. Then we're going to finish that with a publish. So we just want to publish our artifact. And that's going to publish it to an output. Let's call this one .NET Core Simple Web. So .NET publish, .NET Core Simple Web. So let's go ahead and start. Let's go ahead and commit this directly to the main branch. Actually, let's see. This is going to go into a folder. There shouldn't be a conflict between the other one. Let me just create a new branch real quick. It's going to do the run anyway because it's going to do a pull request. So let's go ahead and do that. Let's just do this on the pull request. We'll create the pull request. I just don't want to have issues between the two. Now, once I do this, we should see the pipeline spin up. There we do. And we should be able to watch that pipeline run here in GitHub. So it looks like my Simple Web worked in Azure DevOps and in GitHub. We'll just wait on that one. But you see here in Azure DevOps, VS Build, VS Test, Publish Artifact, everything worked like I expected. So that's a basic CI pipeline in both DevOps and in GitHub Actions. All right. We have a couple labs to go along with this, such as continuous integration with Azure Pipelines and GitHub projects with Azure Pipelines, so that you can see those. And there's also a bunch of them that do CI with ADO as well. So let's go ahead and continue with CD. So now we want to talk about continuous delivery. So when it comes to this, we're talking about taking that build artifact that we've just created in our pipeline and deploying it somewhere. We're releasing it to an environment, whether that's test, production, whatever we're doing. Likely it's some kind of dev testing arena that you can then promote to different stages down the road. Generally requires setting up access to your subscription, which you can do through service principals. We're actually going to use the publish profile for our GitHub actions, so that'll be fun to see that as well. Excuse me. All right. So as we go through working with DevOps and just kind of understanding the things you might have to know in the exam, you're going to want to be in full command of actually a release strategy around the different pipelines that you're doing. So in DevOps, you'll build a release itself. Generally, you could also, of course, do it all in YAML. So you don't have to use the DevOps releases. You can all do it in the pipeline with YAML as code, or you can do it in the release pipeline. If you do it in the release pipeline, then you're going to have a little bit more control with things like release gates and approval gates. And so here you just see a simple image where there's basically a gate showing that you need to approve it, and it's asking for a specific person to approve it. You can also do gates that check for outstanding work items, or potentially check for Azure monitor alerts, or trigger Azure functions. So there's a whole bunch of other things you can do around these gates to see this all in action. All right, so like I said, we're not going to talk a lot. We're going to do. And if you want to see more about what those gates are as we build them, as we take a look at them here, you will need to spend a little time reading that and doing it on your own. We simply cannot cover all of it in this demo, but we're going to hit it, and you'll see a little bit of it, enough to hopefully get started, get your feet wet, kind of understand where it's at. So we built out our pipeline, and so now again, we have this pipeline which we did in YAML. So if we wanted, we could actually continue the pipeline here and do another step. The other one that we saw earlier, let me just show you this quick, is going to have that in place. So that's the Tailspin Toys. And so if we look at this on our pipeline here, this is one pipeline. There's no release. Well, there is a release on this. Probably I was messing around then. But the release that you saw, that it actually was failing. So that failed. Okay. Here, if we look at the pipeline and edit it, you can see that this one has multiple stages. So it has build and deploy, test deploy, and production deploy. So this is doing multiple deployments within there. And then the deploy stage then, so the build stage is similar. This is the one we stole the publish artifact from earlier. But basically then the stage for deploying is then going out and doing some deployment to Azure, as well as this is doing Azure deployment. So you can see that it's very possible to do that through your YAML. It's much easier, especially if you're new, to do it through a release pipeline. Now, in order to make this happen, I have to create a service principal. So what I usually do is I create a service connection, and then I select the Azure Resource Manager, Service Principal, Automatic. So again, we selected the Azure Resource Manager here for the service connection, the Service Principal Automatic Default, and then we're going to go on the subscription level, but note that you could also go management group level or machine learning workspace. Now I'm going to sign in over here. And that's going to ask me to authenticate with probably my two-factor authentication. And okay, we're good. So there's my subscriptions. So I'm just going to use my Visual Studio Enterprise, and my resource group is going to be the AZ-400 EC demos, and the service connection name is just going to be Azure Connection. Now, if you have direct access to your subscription, you actually can just log in and authorize on the subscription, but it's probably better and safer and more secure and easier to control and manage if you just use the service principal and limit what access it has. So this is just the resource group that it's going to have access to. Everything else it shouldn't necessarily be able to do a lot against. So we want to kind of use that. Once I have my service connection, now I can actually do things where I start connecting to Azure and such. So let's go ahead and go back to our pipeline here, and we'll do a release pipeline. And let's also, just to prove this out, bring up our EC. So I spun up some web apps ahead of time. This is going to be the EC demo Simple Web ADO. And so here, and then this is going to show me here it is. So there's nothing there. Okay. All right, so there's nothing there. So we're going to release to a new pipeline here. This new pipeline, I'm going to do an Azure. So, well, first of all, hold on. Before we even worry about the release, let's get the artifact. So remember how we had to publish everything before? The first thing we need to do is grab the artifact from our source build. So that's there. I could go ahead and do that. And then note this is a continuous deployment trigger. I can say yes, enables every time a new build is available. And note that turning that on puts a check mark there. So if it's not checked, that's not turned on here. And then we're going to go ahead and do an app service deployment to an Azure app service. And this is going to ask me what I want to call it. So let's just go deploy to Azure. And then it has one job and one task, but look at this. It also has a after release trigger on there as well. I can also do a scheduled trigger where I tell it I want to run every day. I can tell it to do it on pull request deployment. I can do it on I can require a pre-deployment approval where I say only Brian is able to approve this, otherwise it won't go through. So that's an approval gate. And then of course you can say the user requesting the deployment should not approve it, which is a security thing. And then you can have pre-deployment gates. And here again, you can set how long you want to take to evaluate, and then you can add different gates for policy, Azure function, REST API, query monitor alerts, query work items, or the Sonar Cloud quality gate status check. So you can do all kinds of different checks there to prevent the solution from being deployed automatically without passing some of these things. So you could run a check against your against REST API to make something's there, or a function to validate somebody else approved something somewhere else in a database, and it calls that database and says, yes, I have the approval. Or you can see, you know, something out of policy compliance we're not going to deploy. Or can I see, you know, we have a thing that's running, and so this is more useful if I'm going from QA to prod, and QA is deployed and it's throwing a bunch of errors into my app service, application insights, excuse me. I can query the application insights and make sure that I'm not getting a lot of errors before I let it be deployed into production. So lots of different things you can do there. You'll need to understand all of that for the test. So this is going to be a very simple deployment. We're going to go ahead and say we want to use our Azure connection. We're going to deploy our app service to that Azure Resource Manager, Azure connection, web app on Windows. This one, I can't remember. I think this does have slots, but I haven't created any. So it can have slots, but right now it doesn't. So I'm not going to deploy it to a slot, but if I did, I could go ahead and tell it I wanted to deploy to a slot called staging or something. Otherwise, it's just going to drop it into the default location for that app service. All right, so I'm missing something here. It won't let me choose the app service name for some reason. Yeah, something's not quite right with my configuration. So let me fix this here. We're going to go to the ADO. There we go. All right, so now it knows where it's going. I'm not going to do a slot, so we're good to go. Go ahead and save that. And that's going to create my app service deployment for a release here. And so with my pipeline, I do want to go back and turn this back to on so that it will automatically enable that automatic deployment on build in case I change that later. And then this will trigger that and go ahead and deploy. Now I can go ahead and create a new release here, and so I could do it, go ahead and stage that if I want to do it manually. Let's go ahead and create this. Release 1 has been created and it's deployed, it's queued. And so we can see that that's going to execute here. This agent is ready. And once we start that up, you see that it's going to start spinning here. It's going to tell us what's happening. You can look at the logs as well to watch this happen. So you can flip between the pipeline there and the logs here, just to kind of see what's happening if anything goes wrong or whatever. And that should then go ahead and deploy to Azure, and we should have ultimately at some point then have an app service that's up and running. And we'll let that go. All right, so while that's spinning and deploying, let's go ahead and fix our GitHub action to also do the same thing. So here in my patch branch, I have my workflows, I have my .NET YAML. And so in there, what I want to do is I want to add a step to use the publish profile. So for this one, I need to grab the publish profile. And so I'm going to go out to my GitHub version of the app at Azure. And I'm going to select Git Publish Profile. I'm going to download that to my machine. And once I get that, I'm going to open that in my folder. And you see that that's the publish profile there. So I'm just going to copy that. And then I'm going to drop that into my secrets in my repo. So we'll just add a new secret here. And let's see, we want to call this, let me double check. Yeah, we'll just all caps here. Azure, it doesn't have to be all caps, so I'm just going to do Azure Web App Publish Profile. And then I'm just going to drop that publish profile in there and add that as a secret into my repo. So there it is. And then what I can do then is go back to my YAML. And sorry about this indirect route to that file. And yeah. Like I said, I don't like the UI here at GitHub very often. I have issues getting where I want to go, so I have to jump through 6 hoops to get there. And here we are, finally where I want it to be. You know, ordinarily I would do this on my desktop and just push it. So doing it out here is just fine too. Okay, so the last thing I need to do here to publish this then, I have the publish profile. So that's nice because now I don't have to do any kind of service connection. It's a little less secure because I have a direct publish profile rather than an authorized service connection, but it's in my secrets, so I shouldn't have to worry about it too much. And then what I'm going to do is I'm going to grab that deployment step here and just put it in my YAML. So let's edit this. And this one, I need to change the package to match the simple web that I just created. But you see what it did was it went ahead and it got an environment variable for the Azure Web App name. So I need to add that in. And so let's go ahead and drop that in after there. And the name of this web app is going to be sorry, give me 1 second. AZ-400 EC demo simple web GitHub. It's going to use Ubuntu. It's going to do the same build it did before, and then it's going to publish that simple web, and it's going to drop that. It's going to put it on the app name with that publish profile from that repo artifact. So let's go ahead and commit that to the patch branch again. So now that's there. So we've built our pipeline with continuous integration and continuous deployment all built in. And in Azure, we just did it through the actual release pipeline. So you see the two differences. Here we have this release, which has gates and stuff that we control on it. At GitHub, we're just using GitHub action and we're pushing everything there. So let's just see what we have. So this is the ADO version. and Simple Web is there, and this is going to be the GitHub version, and it's not out there. That's not the right URL, or has never been published. So it's probably still running at GitHub. Let's check our actions. It is still running, so it's still building. It hasn't deployed yet, so we'll still see the old one there. This is the GitHub, or the DevOps version published to Azure. I tried to pre-wire up a database. Let's see if I got it to work. Let's just do Bob. And some simple password. And let's see what happens. If my database is wired up correctly, it should work. And it is not wired up correctly. So, of course, it's not. And let me see what I got here. Simple Web, DB, ADO. No tables were generated. So the migrations definitely were never run. So the registration didn't work. This one went ahead and deployed to Azure Web App. So let's see if that's out there now. I'm guessing I have the same issue with the database connection. So this is a good chance for us to see that quick, so I can fix it. So again, I asked for a little bit of grace with some of the things here. One of them is going to be this. So I'm just going to go to the configuration quickly, and we're just setting the connection string. So this is the wrong app. So we want to find ADO for a starter. So we're going to go to configuration. And then under configuration, we're going to look at default connection, and we're going to edit that. And I'm just going to drop what I think is my password in there for Simple Web Demo AZ-400. Okay. Let's see if this one worked. If it didn't work, it's not the end of the world. It just means that my database isn't wired up, and that's not going to make or break us today. So we'll probably get the same error. Okay. All right, so database isn't working on either one. Let me see if I can take a quick look at this again. And just to verify, it is default connection. I'm looking for default connection. And the server is that one. That's what's wrong. The catalog's wrong. All right. All right. Rather than waste any more time of your time on that, I'm going to just know that if I had set the database connection right, we would have seen the ability to register. What's more important for this is that we have our stuff configured and we're deploying. That's what matters. So All right, so the next thing I want to talk about that's going to be important for the test is deployment patterns. And for this one, what we're talking about is different new modern patterns. So in the past, we had our general step pattern where we said go to test, go to dev, or go to dev, go to test, go to production. And that's great, and it has worked fine. And if you still do that, that's fine. If you're going to take the test, though, you need to understand different modern deployment techniques, such as the blue-green deployment, which is essentially using slots or multiple environments and a load balancer, whether that load balancer is over top of multiple app services or multiple container instances or is Kubernetes cluster manager or whatever, or you're using the Azure Traffic Manager or you're using Azure Front Door as some sort of load balancer to do multiple app services, or you're within one single app and you have slots. So I wanted to show you that within a single app, if you have a standard version or more, you can easily do slots. And so the ADO version is going to be in the standard slot version. So let me just open this in a new window here. And so what's cool about this is I can create deployment slots. I can say I want a new deployment slot for, let's just do staging. We'll call it staging. And note that it's got to have the same name as the other one, and then just dash staging. And once you get a slot in place, then you can build a pipeline to deploy to the slot or the actual full version. As you saw, we had the choice available, or we just named the slot. We're basically in our published profile that we pulled down, it'd be for the slot, and it would then deploy to the slot. And then once you get a slot in place, you can actually do swapping. It also has built-in traffic managers. So let's say I wanted to direct 10% of my traffic to my slot, I could do that. And now 90% is going to the production, 10% is going to staging. This is really nice if you want to do some canary deployment type of thing, although you don't have a lot of control over who that 10% is in this scenario. And if you want more control over that 10%, then you definitely need to use a load balancer that lets you filter by IP or filter by route or whatever it might be to direct your limited traffic to the staging. So in a blue-green deployment, we have stuff that's in our environment, that's in our production. And when we're ready to go, we just say swap, and we swap it out. It then warms up the other slot and gets it so that you don't have any downtime, and then performs the swap. And everything that was in production now is in staging, and everything that was in staging is now in production. And if things go horribly wrong, you push swap again and move your production back to your original production back. And that deployment pattern gives you that really quick way to switch back and forth using slots. Canary releases, all that means is that you have a few people who you call your early adopters, or your very, very basic internal people that are more tolerant to problems. And those are your early, your people who are more technologically savvy, who understand your product well. You release to them first, and they get the new features first. Then they test them out, prove them out, and when you're ready, then you deploy it to the rest of the world. Feature toggles is a good way to start using your code to allow specific features to be turned on and off. This is really useful because you can deploy the entire application with a new feature, even if the new feature is not done, just toggle the feature off. And then also you have the ability to quickly turn things on and off. You have the ability to test your solution in production with the new code, even though you haven't implemented the feature yet to the users, making sure nothing else is broken. Then you turn it on, see what that does to your load, see what that does for your users. Dark launching is a way to, it's similar to Canary, similar to ring testing, but it's a little different because when you do a dark launch, people don't know they've actually got the new feature. You're basically saying, I'm going to push this out, and a few people end up doing the new feature without even realizing that they were available, that it was available. And also, this is another thing you can do with dark launching, but again, be very careful, especially if you're crossing borders, such as the Europe border with all of the new regulations and such. If you want to do some dark launching on metrics, you can do that to gather information about users and they aren't knowing what you're doing, as far as what pages they're going to, what their flows are, all that jazz that you can figure out through application insights. You can do that as a dark launch, and people won't even realize that those features are implemented. Again, if you are doing things where you're gathering user metrics, you probably need to make sure you've put in a release statement to the users, let them know, hey, potentially, or opt out of being tracked on certain things, right? A/B testing is another thing you can do with similar to blue-green, but generally you do 50-50 traffic or 40-60 or whatever you want to do. But A/B testing is really most useful for marketing, for determining copy, for determining which way your users get to your sale faster or which way the users get to the result you want faster. And so you can put out two versions of the same page, A and B. You direct traffic to each one, and whichever one performs better, you make that the version you use. Progressive exposure or ring deployments, that's where you're going to do like the ripple effect, or sometimes called the blast radius, where essentially you push something out into a small version of people, and then you have a ring deployment that goes out to the next version, and then the next version. Kind of that image that you see there is a little bit like canaries, then early adopters, then finally your full users. So we see this a lot with Windows. Windows has an insider program, and so assumingly, I don't know for sure, but I assume that internally, Windows does a release for something like Windows 10 version whatever is next, that goes to a few of the people that they have as their canaries, and then eventually it would go to the people in the insiders program, and then eventually it goes out to the rest of the world, right? That's a ring deployment. It's basically saying, let's get this out there. Let's have our early adopters take a look at it, make sure it's working before we release it to the Gen Pub, right? And so that's what you're doing with that ring deployment. Now, this is useful for both segregations on populations of users as far as what their abilities are and what they're opting in and out of for, do I want features earlier at the risk of error? Or it's also useful, and let's say that you have a solution that needs to be deployed geographically in ripples. So maybe you need to deploy to the East US for like New York or Washington, DC or whatever on the East US. And then you want to then deploy to Chicago, and then deploy to Vegas, and then deploy to Los Angeles and San Francisco, whatever. So different geographical things can also be done as a ring deployment, not just users. So there's a bunch of labs when it comes down to finishing up CI/CD and deployment patterns and deployment strategies that we have available. We have release gates, stuff that you can see practicing with that. We have YAML and ADO. We have ARM templates. Again, we aren't going deep into the infrastructure as code, but that's a big part of building out a full pipeline. You may be also spinning up an environment in that pipeline. You may be creating app services. You may be creating storage accounts. You may be creating VMs to host your web account, web services, whatever it might be. That might be part of the pipeline process. And so using ARM templates is a big deal. Possibly Terraform, if that's your flavor, or Ansible. There's a couple of different options, and all of those things are eligible for the test. So you want to just be aware of these different tools and what they do, what they're for, if nothing else. We also have container labs, lots of container labs, Kubernetes labs, Kubernetes services, different things there. So we're kind of rounding the corner towards home here. The next couple of things we need to talk about is building out the DevSecOps. And so we've seen the pipelines being built. We've seen GitHub Actions and ADO pipelines. And what we need to know now is that those are great and everything's automated, but we haven't done a lot to protect ourselves as far as security and different compliance issues that are possibly happening. Right now, any developer could check in code, and as long as a human approves the pull request, it would get pushed into our environment as an artifact. Well, there are tools that we can use that allow us to build out a better rugged DevOps process. We need to be aware of these for the exam as well. So things like managing your configuration and secrets. So we saw a little bit about the app config when I was messing around with the connection string for my database that didn't work. The app config itself on the app services is a great way to obfuscate things from the user. They don't have to necessarily then know how to connect to your database because it's done at the app service. But even farther, there's a thing called Azure App Config, which takes it even out of the app service, and then you need to have the right permissions to do that. But even deeper than that is Azure Key Vault with your secrets. So now what you want to do is create your secrets at the deepest level in Azure Key Vault And with connecting to Azure Key Vault, you have to be able to then, using Azure Key Vault, you have to set up access policies so that only the right people can see them and modify them, and then only the right processes have permission to get those values when they need them. Additionally, to configuration and secrets, we have dependencies. It's absolutely almost impossible in today's development environments to build an application that doesn't have components, and those components generally include components that are written by someone else. So .NET, we have all the NuGet packages. JavaScript, we have all the NPM packages. Java, we have Maven. So that almost everybody has some sort of repository of third-party artifacts. As you start building those and having those in your code, you potentially are opening yourself to security issues. And so you want to make sure that you are scanning that code for any issues. And then also, you may have a situation where you need to make sure that you're on a specific version of an NPM package or a node package. And you all know what I mean when I say this, because those get updated faster than we can adapt at times. And we need to be on the latest if possible because of security issues. But there are going to be days that we have a new NPM package or a new node package, a new NuGet package, or whatever it might be, Maven, POM thing, that you brought in for Java, and it just breaks everything. It just breaks. And so what do? Well, you can exclusively set your, config files to use a version. Usually, that's great, but it may be also the case at some point that version is no longer available. Then what do? Okay, so at Azure DevOps, there's a thing called Azure Artifacts, and what you can do is you can bring in all of those third-party dependencies and put them in a private feed that you create. You can also use things like MyGit for NuGet packages, and I know that there's public ones for Java and for NPM, but I don't know what they are off the top of my head. But if you create an account, you can create private repositories there where you're actually publishing your own code. You can then use that version in your code as your dependency. Even if it isn't available anymore from the fully public one, you now have the version you need, and you can use that in your code. It's also useful if you are creating components across an enterprise that need to be shared, and you can have a repository of these components that are available. And so you want to have some sort of package dependency archive in place to make sure that you don't lose those dependencies, but also, again, that you can scan them and be fully compliant with anything that you need to do with licensing, as far as MIT license versus, new public license, GPL or whatever, which ones you're using in your actual feeds. You need to configure all that and make sure that you have the right versions with the right licenses and that you're not doing something to violate a license to stay in compliance. You need to be able to manage all that. And so having your own dependency feed is generally a good idea to help mitigate some of those scenarios and assume that you will keep that up to date as much as you possibly can. All right, so what I wanted to do here is a demo on using Sonar Cloud and White Source in my Azure DevOps pipeline. Hopefully I can pull this off. I'm just going to again ask for a little bit of grace as we walk through this together to try to get these to work. And they're not hard to implement, it's just I don't do it enough to have it memorized on how to do it. So yeah. So that's the Parts Unlimited app that is available and I have here for my demo. And right now I have this White Source Bolt installed on my actual machine or actual DevOps. So what you can do when you go out to Azure, you can go to the DevOps Marketplace and you can look for different components. And so, for example, I'm using White Source Bolt and maybe just white source. And so white source allows me to get that into my DevOps environment and make sure that it's installed. And it should tell me, I think I already have this one. Maybe I don't. Okay, so that would explain that. So that one's not there. So now it's on my organization now. So the other one that I want is Sonar Cloud. So let me grab that one. And make sure that I have this on my DevOps organization as well. So I do have that one already. So both of those are now installed. They're both free and they're available. With White Source, I need to have given them an email in order to make this work. And I think I've already done that 100 times, but let's see what we get here. So when I look at my pipeline, the reason I wanted to use this one is because this is a lot easier to do with the classic pipeline. So this one should have the classic pipeline in place. Now what I should be able to do here is I should be able to add steps to do some scanning. And so if I want to add a step here, let's try to do Sonar Cloud, for example. So run code analysis for Sonar Cloud. And then let's also bring in, and again, please bear with me, I may be doing this completely wrong. I'm mostly just trying to do this from memory at this point. I must have grabbed the wrong one. Sorry. All right, let me try this again. All right, let's come back to that part. Let's just do this one with this, sorry, just to save quick. All right, so on my code analysis, I need to set this up so that it'll actually run on my code. And then is there a, yeah. So you can use it as a quality gate. You can do other things with it. But what I really wanted to do was get this set up. And I thought that I would have to configure this with some projects. Okay, let me go ahead and run this pipeline. And we'll kick that off for a second and see what happens. Because I was thinking that I had to install at Sonar Cloud a project. So if I go to Sonar Cloud, so here's one that I've done in the past. And generally you create a project and then you create a service connection inside of your pipeline to point to Sonar Cloud. It then shows you things that are wrong with your actual build. And so here I can go in, I can see I have 87 bugs and I can look at these bugs and see, I have 2 critical things that are wrong. And so this is my static scanning that I've done with Sonar Cloud. So I build that into my pipeline. It then says, hey, go fix this stuff. Yeah, I got code smells, like, add a nested component. Now, the nice thing is that I can go here and I can say, okay, I'm probably not ever going to change this. So let's go ahead and, put this to resolve as won't fix. Okay, and then I give it a message that says, just not going to do it or something. And comment that. Sorry. And so I'm just not going to fix that. It's resolved as won't fix. And then if I go back, now if I look at my overview, I only have 86 bugs. So I'm getting closer to being ready to deploy this and get it out there. You have issues, you have your security hotspots. So it talks about different things like different vulnerabilities you have in your code that could be wrong. Different measurements here that it's got just some graphs on, different things that you can see. You know, it looks like it's guessing I can remediate most of this in a day and a half. You know, my security rating is terrible. Maintainability is not terrible. Code coverage is 0.3%, which is terrible. Uncovered lines of code, almost 20,000, 19,000 lines of code. So really nice part of things that I can do to just scan my code repository. And so that's what that's for. And when I run the pipeline, then it should automatically run that scan. And then I don't have it configured here, but we don't need it for this demo. You've already seen what it would do. Once it's wired up correctly, you would be able to then look at that and review all your scan results right there at the Sonar Cloud. Now, the free one does make everything public. So obviously, if you're going to use Sonar Cloud, you don't want to use the free version for your enterprise because you don't want your security issues out there for the whole world to see. So make sure you don't do that publicly. With White Source, I wish I had this working better because White Source is really cool because it tells me things that are wrong with my NPM packages. So when I go to my pipelines, I should have been able to add in a White Source step. Okay, there we go. So now I can add White Source bolt, and I'm not really sure what the difference is here. Different versions or something. And I think they actually might be retiring White Source bolt and going full White Source security now. You can see here, this is just, you know, a project or something. And you can do different options. And this White Source is similar. And I'm wondering if the project name has to map to something at actual White Source now in order for that to work. So let's go ahead and just save and run this. I'm not sure what's going to happen here, honestly, but you see when it runs, I should get some sort of, yeah, so I don't have this wired up with my organization connected at White Source. But this one, yeah. So this one will show me something here right in DevOps, but the new one, the more robust version, you'll go out to White Source itself, create an organization, and get wired up so that you're actually doing your stuff at the White Source site. But either way, the whole idea is at some point you need dependency scanning. You need to be able to look into your code. So you need static analysis, you need dependency scanning, and then ultimately it would be really nice to know how to integrate secrets into your pipeline as well. And so we have labs and all this stuff as well that you could run through. If you take our course and walk through the labs, you would get a chance to play around with all of that stuff. So the last things come down to site reliability, monitoring, reporting, and then basically communicating with each other, and then setting up our project boards. And so I save these till the last because I feel like the meat and potatoes of this situation, the meat is all the CI/CD and security, and the potatoes and the salad that you want to have with your meat is the stuff that you finish up with here. And so we have our site reliability engineering plan. This is basically just making sure that we have resilience, that we can handle incidents, that we have instrumenting in place to make sure that we don't miss errors that are happening, that we can get reports and alerts on those, but that we don't get too many alerts. So we want to make sure our alerts are balanced, that we're getting the right kind of alerts and the right frequency, because there's nothing worse than a noisy alert channel. It will just get ignored, or a lot of emails, they'll just get ignored. Load balancing, of course, to help us with load, scaling to help us with when we have demand, resilience and fault tolerance built into our code and built into our architecture, so that if a VM goes down, we can fail over to our backup region, or if the web app decides not to work for some reason, our load balancer directs to the other one. Just know that things like Traffic Manager, Front Door, those load balancers, they're going to automatically do health probes on all the things they're balancing to. And if one of them is going to go down or is down, that load balancer will know to just send your traffic to the right people. So you're gonna, or to the right people. Send your people to the right server so they don't notice any downtime. So this is standard Monitor, Azure Monitor stuff. This image here, I just stole it off the Microsoft Docs for Azure Monitor. But you can see the idea being there's two different types, metrics and logs. Metrics are going to be your general metrics like CPU, requests, how much hard disk you're using, is your CPU spinning 100%. And those metrics are things that you can set automatic alerts on, that you can then send emails, SMS, you can post to Teams or Slack. You can trigger Azure functions, or basically anything you can do with a webhook, you can do from an alert. So just keep that in mind. And then logs, that's where it gets a little deeper. So the metrics are nice little things that are, this is our dashboard. We're gonna have a bunch of little gauges that are showing everything's running and tuned the way it should be. Logs is where we go when stuff really goes wrong, or if we want to find out more deep information. We use a thing called the custom query language, and that custom query language allows me to write queries to find things like the exceptions that have happened in the last 24 hours, or exceptions where the type was this, or whatever I need to do to figure out more deep information that's been instrumented into my systems to help me determine where it's gone wrong. So we have application insights, we have VM insights, and we have container insights as well that we can use to monitor our containers. So we have different types of insights that we can make sure that we have those in place. We can create dashboards within application insights itself, or within our Azure environment. We actually have workbooks and boards that we can build, different views that can be static. Of course, the new hotness is Power BI, and everybody's wanting to get some stuff and dashboards into Power BI because that's where your business analysts and where your business logical people are going to live, more in the Power BI. So the more you can send to them there, the less that they'll call you, or more, maybe more if you send them too much information and they want to know more. But the idea is get them dashboards that they can use to make actionable choices, and put it into Power BI so that they can easily get to it, and they don't have to have all the technical skills around Azure that you have. And so you get all this working together in a well-oiled machine, and you get rugged DevOps with security. You get releases that are getting your cycle times lower. You've moved your quality left. Now you've got reporting and things that your team can read to know that things are working the way they want, and make even further decisions. And that's the whole idea. And that cycle just keeps repeating itself until you get to the point where you continuously get your cycle time lower. So that cycle time being the idea of how long it takes to get from conception of the idea into actual production. That's your cycle time. So if I have an idea, and then I have to go through requirements, and then I have to go through these checks, and then it's a monolith, so we have to wait 6 months until the next monolith release. I'm just kidding, but you know what I mean. And so we get it out there as fast as we can. That's the idea. The next part's an instrumentation strategy. This really comes down to actually getting that stuff implemented. And there's a couple things here, the main one being application insights for web apps, or just, again, the container insights, or the VM insights if you're looking into those things. But metrics, logs, getting a workspace built, getting dashboards, using custom language to build your queries, instrumenting your web apps with code. It's supposed to be code, sorry. Hopefully you find that as entertaining as I do. All right, so it's easy as right-click and publish to literally get app insights on a web app. And so you just right-click, add it in, and then you have that as a connection string. And that connection string is also available on your application in the configuration, so that you don't have to do a lot. And so what I wanted to do was use this application insights quickly. So on a .NET web app, I just right click and I say add application insights telemetry. And I'll go ahead and, you know what, actually, before I do any of this, we made a bunch of changes in GitHub on both GitHub and ADO. So let me just go ahead and, this will be the fun part, right? Git fetch origin. There shouldn't be much changes to the main there. So the new branch for patch is there. That's fine. Let's git fetch ADO. Okay, and then git pull ADO. So we'll pull down the changes. So now at least main is up to date with ADO. It's not up to date. The other branch is not up to date. So if I go to git checkout Brian demo commands or whatever it was on. Sorry, that's not the one I want. I wanted, it doesn't even show it there. So I wanted this new branch, which is BL Gorman patch one. And then let's go ahead and rebase the main from ADO onto that. And then we'll go ahead and push that out to BL Gorman patch one. See what happens. Yeah. Okay, and so the tip of the current branch is behind, use its remote counterpart. Okay, let's just do git push origin. Okay, so now it's up to date. This will be interesting. I probably created all kinds of conflicts, but whatever, I don't care. Now I have the latest version on that patch as well, which should have my pipeline from ADO in it. This is why you don't want to use two repos, because it becomes multiply messy. Okay, but we should have, both of them should be up to date. I should be able to push to main on ADO. I should be able to push to whatever at GitHub if I wanted to. So now I'm going to right click and I'm going to add application insights. It tells me I have some service dependencies. I need a secrets local if I want. Then I need application insights. So let me just try this again. And let's just use Azure. And then I put another one out there just because I wanted to make sure that I didn't step on anybody's toes. And so this is the EC demo developer insights. So locally, I'm just going to use developer. I'm going to tell it to use the local secrets, which is amazing, but it doesn't ever do it right. I don't know why. It puts them into the secrets, but it also puts it into the app settings. So you generally don't want this in your application settings, right? This tells anybody in the world how to connect to your application insights. So you would generally pull that out and put that into your developer secrets. And it has it in there. So I'm not 100% sure why, other than their different names. So this is application insights connection string, and this other one was, application insights connection string. It's not the same. So I think if I took this right here, if I took this right here, I think, and just put this into here, into my secrets, I could then remove it from my app settings altogether, and it should still work. Even though it's not in my local now, it's still in my secrets, so it would think that it's going to work. And we'll be able to tell if this is working in a second. So here's my developer insights. And I'm going to just go ahead and go here to live metrics. And if it's working, I'll get a live stream, even from my desktop into Azure, which is pretty cool. So you can see the metrics that are there. Wherever my web app is that it's running. It's way down there, okay. There it is. So as I do things here, I don't have any custom metrics wired up, but hopefully we would see some metrics happening. You see a few things happening there. So even though I'm local, I'm tracking it. But the cool thing is now that I have application insights installed on my app, I can push this out to Azure DevOps and to GitHub, and their pipelines should trigger and then should deploy, and then I should have them at Azure Web Apps, or Azure Web Apps. So let's go ahead and get, let's see, so this one, This will be interesting because if I commit here, let's just do an Azure DevOps thing. So you see that I have the service dependencies, simple web solution, startup app settings, and service dependencies that are all created, added for the application insights. So let's just go ahead and do a git add dot git commit. And again, you should not be developing on main. You should be developing on develop onto your feature branch, which I'm not doing. So you should be doing that. Don't do as I say, not as I do. So here we're just going to say git commit and added insights. Then we'll go ahead and git push ADO. I think I can just do that. And then let's go ahead and git push origin. This might not be happy with me. Okay, that actually worked. But then let's go back to BL Gorman patch 1, and then let's go ahead and rebase back on, let's do, well, we can just do main at this point. Git push, oh shoot. This is origin, BL Gorman patch 1. I shouldn't have to force. I do have to force, funny. All right, so fun times when you rebase, right? Okay, so we now have everything pushed. Let's see if we got some pipelines running at this point. For Simple Web ADO, we do have the pipeline running here. And so this should then push and have the insights on the web, and we should be able to see that out there running against its own insights. And just to show you that, on the app service itself, basically in the configuration, it has the instrumentation key right there. And so it knows to use that, and it's going to be set to the instrumentation key that's different than my dev. So that's how I can separate my developers from my actual instances out in production. Once I have insights in place, the key thing here is just to know how to create alerts. So let's say that I want to go off of the GitHub one. I can create an alert here. I want to do a new rule, and I can create, this is, let's do off a metric. Let's do off a, let's just do all, and we'll just do exceptions. And so any exceptions that happen, what I can do then is say, in the last 5 minutes, evaluate every minute. If there are greater than, let's say, a count of 1, then that will trigger. So we'll go ahead and do that. You see it costs me 10 cents a month for every metric that I check. So if I have 10 things, it's going to cost me $1 a month to set alerts for this app. So it's super cheap. And then my action group would just be, I'm just going to use one I've already created, but you would create your email, and you can send it to, or send your action group, which would be like your support team. You can send it to your email, you can send it to SMS, you could push it to a webhook. And so with that, then whenever this is triggered, I would then get an email. So my alert name would be send support email. And then description is going to be, this is the alert failed. And I think they listened to me because look at that. They have colors on these now. That is amazing. So if you aren't familiar with this before, this didn't say this. It just said 0, 1, 2, 3, and 4 and had no colors and no words. So they must have heard me complaining because I was like, what do these even mean? And here we go. They finally fixed it so that you can use this in a logical way. So let's say that this is an error. And then we'll go ahead and enable it, create it. So now if my application that was pushed by GitHub throws an exception for every 5 minutes, in the last 5 minutes, checked every minute, it will send me an email that says you've got a problem. And so that's alerting, and just again making sure your alerts make sense and that they line up with your initiatives that you want. All right, so we have labs around all this as well. We have application insights, we have load balancers, application gateways, Azure Traffic Manager, Azure Front Door, Azure Monitor, and alerting, and then we have a thing that's called the Azure Challenge Developer Fundamentals, which is a special event that we run. And then the last part of today's little walkthrough for us is the Azure boards. So GitHub also has teams with tickets and boards and issues as well. You may be using Confluence or Jira or something else. At some point, some way, somehow, you need some sort of board to track your work. And in the DevOps exam, just be ready to know what the DevOps boards do and how you can work with them. But even if you don't use this in your work, the exam, this is part of the exam. So know what it means to have work items that are being tracked, the difference between Agile, Scrum, CMMI, and basic or simple, which is just a regular Kanban board with a to-do, a doing, and a done column. Understand what a backlog is, understand what a sprint is, know that you can query work items, bugs, epics, all this stuff. You can do all of that at Azure DevOps in your boards. You can manage your teams. You can work with different teams as well to have different initiatives as far as epics, different teams assigned to those epics, however you want to make that happen. And then another big part of the exam is going to be integrating with your messaging clients. So Teams, of course, being Microsoft's big player, know what it means to work with Teams against Azure DevOps, but also how to wire all that up, how to use webhooks to communicate, so things like Slack, or even other things that you could happen. So you might have an alert, for example, that we just created an alert. You might have an alert that triggers a message to your Teams channel that says, hey, we need you to go check this thing out. Or you might have other things from your build process also logging into Teams channels, like as my CI pipeline failed. What happened? Go check it out. So know that integrating Azure DevOps into Teams is a big deal, as well as maybe not Teams, but Slack, or one other client that you could easily understand how to work against the different solutions. At the end of this, I always like to close up with a few additional resources. So I'll point you in the direction of MS Learn. There's a collection I made that basically contains the entire solution of Azure DevOps stuff. So if we went out to the AZ-400 exam, for example, you would see here that there's the skills that are measured. This was just updated yesterday or 2 days ago. But they have two ways to prepare. Instructor-led, you can come to our 5-day training and take that and go really deep, or you can start working through the plans on your own. You can see there's quite a few here, and I haven't done them all, obviously. So again, do the ones that you're not super familiar with, do the ones that are weighted heavier, but if you can do them all, it would be much more useful to you. There's never been a time when I've taken one of these and didn't learn something. Even though I might think I know security and compliance, for example, I completely didn't even go into that one because I've seen it in different things, and I actually am doing a blog post on that for tomorrow for the Azure Spring Clean event. So like, it feels like I don't need to spend a lot of time there. I didn't do it, but I guarantee you, if I went through those 11 modules, I would learn something, even though I didn't do them. The documentation that it takes you through is fantastic. So you get to walk through stuff. A lot of times when you do this, sometimes it'll spin up a sandbox. So you see there's just all kinds of cool stuff that you can learn. It's all organized well. Then they have little exams at the end to kind of check your knowledge that give you, stuff on there. But you can also create collections. So I've created some collections, and one of them is the AZ-400, which is that link that I had here. And that link just basically is the collection of all of the different AZ-400 modules that you saw, and maybe I might have thrown a couple more in there because you can always add to your collection along the way or whatever. But you can see 60 hours of study. I did about half of it, so obviously you want to spend a lot of time there. And yeah, so there's that. The docs themselves, Learn Cloud Challenge, I wanted to do that because this is also a really cool thing. And depending on, sometimes like with Microsoft Ignite that was just happening couple, like last month, I think, they actually gave away an exam voucher. So this is the Microsoft.com Learn Client Challenge. So you can go out there, sign up with your account, tell them that you want to take the AZ-400, and basically sign up, and then you get put into a board. So I think I'm in the 303 right now, and I have 0 time to work on it. If I sign in, let me see what I got here. If it'll let me sign in. It won't let me sign in. I'm not sure what's going on there, but I had signed up at one point for this cloud challenge that for the 303. And what I wanted to show you, I can't show you because they can't figure out how to get logged in, but you get a leaderboard of all the other people that are in it, and hopefully, yeah, that's weird. Okay, maybe it's closed down or something, but usually they run every month, so you usually have until the end of the month. So I would wait till April 1st to start a new one at this point, and then once it's done, they'll if there's awards or vouchers or things that you can earn, they'll give them to you. But I can't guarantee that. Sometimes there is. Most of the time, I think there isn't. Like I said, for the one that was just out there for the Ignite challenge, there was one that gave an exam voucher as well. Microsoft documents are amazing. There's thousands and thousands and thousands of pages of documents you can read through. I follow a couple people that cloud advocates for Microsoft, Thomas Maurer. He does a lot of really, really good work, just low-level implementation things that are nice to see someone who knows what they're doing run them. So I recommend following him. And also, his study guide wasn't super awesome for the AZ-400, the one that I found here, compared to what his other ones are, but he's got all the other ones, and you would love to read through those if you're taking any other exams. Tom Wexler, I found, did this one on how he prepared for the AZ-400 exam. And then a guy, Shivam Sharma, and I'm sorry if I sorry if I said your name wrong, just actually found his the other day on Medium when I was looking for resources, and I thought this one is really good too. So I went ahead and brought his into this list just because the more the merrier, right? The Azure poster is just the nice way to see what things are available. So if I wanted to, whoa, crazy. All right. So Azure poster. Too many E's. I'm starting to get tired. So the Azure poster. That's not it. Become Microsoft certified. Here we go. This is where all the exams are. So if you ever want to go out here to see what other exams are available, you don't have to do just Azure. There's 365, Dynamics, Power Platform. Probably you're over here. You have to do 104 or the 204 before you take the 400. But they also have other specialties like SAP, virtual desktops, and IoT. They have the fundamentals, which I'd recommend everybody take the fundamentals. Even if you think you're an expert, again, I guarantee you'll learn something, and just having that general overview will help you on any of these other exams. Like the 204 and the 104, there's stuff in the 900 that will make those easier. Now, you could do these without it, and they even let you do that. But if you want to take the route, if you don't have any exams passed, start with 900, then pick your flavor, 104 or 204, and finish up with 400. Okay, so my pipelines ran. I wanted to clean up or just kind of take a quick look here to make sure, that so if I go out to Azure, and let me just pull up I had it open already. So here it is. If I go to my application insights is grayed out. That's fantastic. Why is it grayed out? That's strange. Okay. So that one's not working. Did I accidentally not deploy this? No, that can't be right. It's got an instrumentation key, so it's got to have been deployed. That is very strange. I'm not sure what I did wrong, but what my goal was I was hoping that I could come out here and show you that, you know, we deployed with application insights from our pipeline, but it didn't quite work. So not 100% sure what happened to the application insights here. I've never seen that before. But that's what happens when you do live stuff, right? Nothing ever goes the right way. Okay, so final thoughts then. Let's go ahead and close up for the day. Thank you so much for sticking with me through all this. Hopefully you found this useful and gained some insight on different parts of the process, things that you need to dive in and study more, or got the refreshing information you needed that you get the confidence you need to pass the exam here soon. So final things that we didn't really cover a lot today. Again, there's just no way to cover all this material in detail in a 2 to 3 hour lecture. So take some time. Everything that's eligible to be on the exam, lots of the stuff that could be done through Azure CLI or PowerShell. And I would recommend becoming very, very familiar with those, especially around things like key vault secrets, deployment templates, querying, making sure you can do resource groups. I mean, the basic stuff, setting up web apps, if any kind of container work, understanding, you know, Kubernetes commands, kube control, or however you want to say that, KUBECTL, the commands for that, Docker commands, you know, how to push to an Azure container registry using the login. I didn't show that. I don't know that I have one handy. I would like to show that if I have one handy, but I don't know that I do. I do. Okay. So when you create your container registry, you know, there's a container registry, and the container registry has a login server. And then under the login server, you also get access keys. Obviously, let me just double check I'm not giving away the farm here. Yeah. All right. So this right here allows me to get my login information. So I have my login server from a registry name, which is public, and it's a URL, so it has to be unique. But then I push this button here, and that gives me my login information for my user and password. So just be familiar with that too. But the PowerShell commands, the CLI commands around any of the things that you could do with secrets, with containers, with groups, with resource deployments, ARM templates, you know, those types of things are all eligible to be part of this, because you are going to expect, you're going to be expected to be able to administer and deploy solutions that require infrastructure as code, as well as knowledge of dev solutions, such as being able to put application insights into play, understanding how the instrumentation key and connection string can work to add that telemetry, what the differences are between metrics and logs. So yeah, I always say understand how to write C# code, even though you might be a Java developer or a Python developer. Almost all of the exams have C# code in them as the default from what I've seen. And there's really, I don't think, any way to change that. So if you're a Java developer, just know that C# and Java are extremely similar. They're both object-oriented. They both use the brackets syntax. The difference is just going to be minor in some of the implementations here and there. You shouldn't have a lot of trouble interpreting C# if you know Java. You may not be able to write it from scratch, which you generally don't have to do. It's going to be a lot of, you know, drag and drop the right code in, and you might have to implement, choose the right pieces of code, which would be interesting. But yeah, so, and then just total understanding the process. Know when you're going to scan, when you're going to, oh, I didn't talk about like penetration testing. which happens after the deployment, using OWASP, things like that. All of those different deep level security scan things that you can do. Know which part's going to be done during the pipeline and which part's going to be done after release. Understand, which part of the pipeline is for building and which part is for deploying, understanding where you can put secrets, difference between DevOps and GitHub. Probably have to get good command of both of those at this point. All right, and so just kind of a quick, wrap up to finish the day then. A couple things went wrong, sorry about that, but hopefully you got the general idea of how everything should work. We have AZ-400 exam. We covered the topics for source control, storage, security, instrumenting and alerting, and then resources. And so the serverless and third-party solution that should not be there. That's left over from AZ-204. So I apologize, it's a typo. But we were able to also see, communication where we build out the board and stuff. So, all right. So that's all I have. So thank you again for meeting up with me today and listening to the AZ-400 exam cram. My name is Brian Gorman. I'd love to connect with you at BL Gorman or Brian L. Gorman at LinkedIn. And this has been a presentation from Skill Me Up. Thank you very much. Good luck on the exam.